Your feet approach the black hole faster than your head does, and at that point, you snap into two segments, right? And then each of those two segments eventually snaps into two segments, from 1 to 2 to 4 to 8 to 16, and you're the stream of particles descending down. The concept of black holes has mystified humanity for over a century. These enigmatic cosmic objects, born from the collapse of massive stars, seem to defy the very laws of physics as we know them. Their immense gravitational pull traps everything that comes too close. Even light itself cannot escape. For decades, black holes have been seen as the ultimate cosmic mystery, their inner workings hidden from view, shrouded in darkness, both literal and figurative. But now, according to Neil deGrasse Tyson, we might finally have some answers. What's inside a black hole? Is it a bottomless pit that leads to nowhere? Is it a gateway to another universe? Or perhaps the end of everything? These are the questions that have haunted physicists and astronomers for generations, and now with new discoveries, advanced simulations, and unprecedented observations from powerful instruments like the Event Horizon Telescope, humanity is closer than ever to unraveling the terrifying truth. To understand what might be inside a black hole, let's first explore what a black hole actually is. When a massive star exhausts its nuclear fuel, gravity takes over, and the star collapses under its own weight. If the collapsing mass is sufficiently large, typically more than 3 times the mass of the Sun, the star's core becomes so dense that it forms a singularity, a point of infinite density where the known laws of physics break down. Around this singularity is the event horizon, the boundary of the black hole. Once something crosses the event horizon, there's no turning back. It's a point of no return, beyond which not even light can escape the black hole's gravitational grip. And here's where things get truly strange. Inside the event horizon, space and time behave in ways that defy our everyday experience. For years, scientists have debated what lies beyond this mysterious boundary. One popular theory, based on Einstein's general relativity, suggests that at the heart of a black hole is the singularity, a point where gravity becomes infinite and the fabric of spacetime is infinitely warped. In this view, the singularity represents a breakdown of physics as we understand it. Time ceases to function, space is compressed to nothingness, and the very concept of inside becomes meaningless. But Neil deGrasse Tyson and other leading astrophysicists are now entertaining ideas that challenge this traditional view. Recent breakthroughs in quantum mechanics, string theory, and the study of information paradoxes suggest that the singularity might not be the final word on black holes. Instead, black holes may harbor something even more bizarre. One of the most tantalizing ideas comes from the field of quantum mechanics, which governs the behavior of particles on the smallest scales. According to quantum theory, information, defined as the state of particles and energy, cannot be destroyed. This poses a serious problem for our understanding of black holes. When matter falls into a black hole, it seems to vanish from the universe, along with all the information about its properties. This apparent contradiction has been dubbed the black hole information paradox, and solving it has become one of the greatest challenges in theoretical physics. Some researchers, including physicist Leonard Susskind, have proposed that black holes may not destroy information after all. Instead, they might encode it on their event horizons. In this scenario, the surface of the event horizon acts like a cosmic hard drive, storing vast amounts of information about everything that has ever fallen into the black hole. This idea, known as the holographic principle, suggests that black holes are not bottomless pits, but rather intricate data processors. But what happens to that information inside the black hole? Here's where things get even stranger. Some scientists speculate that black holes might not contain singularities at all. Instead, the intense gravitational forces could create an entirely new state of matter, unlike anything we've ever seen, known as Planck stars. These hypothetical objects are so dense that they resist further collapse, preventing the formation of a singularity. In this view, black holes are not cosmic voids, but rather highly compressed regions of spacetime, pulsating with unimaginable energy. Another groundbreaking idea comes from loop quantum gravity, a theoretical framework that attempts to reconcile general relativity with quantum mechanics. According to this theory, the fabric of spacetime is not continuous, but rather consists of tiny discrete units called quanta. Inside a black hole, spacetime could collapse into a highly compact quantum state. If loop quantum gravity is correct, the singularity might be replaced by a finite, structured core, a cosmic knot of spacetime itself. Even more mind-bending is the possibility that black holes are gateways to other regions of the universe, or even other universes entirely. This idea is inspired by the concept of a wormhole, a hypothetical tunnel through spacetime that could connect distant points in the cosmos. Some physicists, including Kip Thorne, have speculated that the extreme conditions inside black holes could give rise to such wormholes. If true, black holes might not be the ultimate dead ends we've long assumed, but rather portals to new dimensions of reality. But there's a catch. For a wormhole to remain open, it would require the presence of exotic matter, a theoretical substance with negative energy density. While no such material has been observed, its existence is not entirely ruled out by the laws of physics. If exotic matter does exist, it could hold the key to transforming black holes from cosmic enigmas into interstellar gateways. The idea of black holes as portals also raises profound philosophical questions. If black holes connect different parts of the universe, could they serve as conduits for information or even life? Could advanced civilizations harness the power of black holes for exploration, communication, or energy? And if black holes lead to other universes, what does that mean for our understanding of reality itself? These questions push the boundaries of science and imagination, forcing us to confront the limits of human knowledge. But let's not forget the dangers. Black holes are not just theoretical constructs. They are real physical objects, and they pose a significant threat to anything that ventures too close. The gravitational forces near a black hole are so intense that they create tidal effects, stretching and compressing matter in a process known as spaghettification. For any object unlucky enough to fall into a black hole, the experience would be nothing short of catastrophic. The intense gravity would rip it apart, reducing it to its most fundamental components. Yet, even in their destructive power, black holes might hold the key to some of the universe's deepest mysteries. By studying black holes, scientists can gain insights into the nature of gravity, the behavior of spacetime, and the fundamental structure of reality. Black holes challenge our understanding of physics, forcing us to rethink everything we know about the universe. One of the most significant breakthroughs in black hole research came in 2019, when the Event Horizon Telescope captured the first-ever image of a black hole. This historic achievement provided direct visual evidence of a black hole's event horizon, offering new clues about their structure and behavior. The image revealed a glowing ring of light surrounding a dark central region, a visual representation of matter heated to extreme temperatures as it spirals into the black hole. But the image also raised new questions. Why was the ring asymmetric? What causes the light to behave in such complex ways? And most intriguingly, what lies beyond the darkness at the center of the image? These questions have spurred a wave of new research, with scientists using advanced simulations and cutting-edge technology to probe the secrets of black holes. In the years since the Event Horizon Telescope's breakthrough, astronomers have made even more astonishing discoveries. In 2022, researchers detected light from behind a black hole for the first time. This phenomenon, predicted by Einstein's theory of general relativity, occurs when light bends around the black hole's intense gravitational field, allowing us to see what's on the far side. This observation not only confirmed the predictions of relativity, but also provided a rare glimpse of the hidden regions of the universe. And then, there's the discovery of gravitational waves, ripples in the fabric of spacetime caused by the collision of massive objects like black holes. First detected in 2015, gravitational waves have opened a new window into the cosmos, allowing scientists to observe the universe in ways that were previously impossible. By studying these waves, researchers can learn more about the behavior of black holes, their interactions with other celestial objects, and the conditions that existed in the early universe. As Neil deGrasse Tyson has often emphasized, black holes are not just scientific curiosities. They are fundamental to our understanding of the universe. They challenge our assumptions, push the boundaries of knowledge, and force us to confront the most profound questions about existence. What are we made of? Where do we come from? And what lies ahead in the vast, uncharted expanse of the cosmos? The answers may be terrifying, but they are also exhilarating. Black holes remind us that the universe is far more complex, mysterious, and awe-inspiring than we could ever imagine. And as we continue to explore these cosmic enigmas, we are not only learning about the nature of reality, we are also discovering what it means to be human, to question, to wonder, and to seek the truth in the face of the unknown. So what do you think lies inside a black hole? Is it a singularity, a portal, or something even more unimaginable? Whatever the answer, one thing is certain. The journey to uncover the truth about black holes is just beginning, and it promises to be one of the most thrilling adventures in the history of science. Black holes have captivated the imagination of scientists, writers, and thinkers for decades. They represent a paradoxical blend of simplicity and complexity, a perfect storm of cosmic laws that bend and break the very framework of physics. To extend our exploration, let us delve deeper into not only the science, but also the philosophical and existential implications of these enigmatic phenomena. What do black holes mean for our understanding of the cosmos, for life itself, and for the fundamental nature of reality? Let's start with the intriguing phenomenon of black hole mergers, which have been recently illuminated by the detection of gravitational waves. When two black holes orbit one another and eventually collide, the result is an event of unimaginable violence. This merger releases energy in the form of gravitational waves, ripples that stretch and compress spacetime itself. What's mind-boggling is the sheer amount of energy involved in the brief moments of the merger. The gravitational waves carry away more energy than the light emitted by all the stars in the observable universe combined. But what happens to the two black holes after they merge? Do they simply combine into a larger black hole, or does something even more exotic occur? Simulations suggest that the resulting black hole rings down, emitting gravitational waves in a series of oscillations before settling into a stable state. However, some physicists speculate that the merged black hole could exhibit temporary phenomena, such as a naked singularity, an exposed point of infinite density that defies the cosmic censorship hypothesis, which suggests singularities are always hidden within event horizons. The cosmic censorship hypothesis, proposed by Roger Penrose, is an intriguing idea that attempts to maintain the order of the universe. According to this hypothesis, the universe hides the singularities created by black holes from external view, ensuring that they do not disrupt the overall structure of spacetime. If naked singularities could exist, they would expose the raw chaos of infinite density, potentially leading to violations of causality and the breakdown of physical laws. But recent mathematical models suggest that in certain extreme cases, such as the collision of highly spinning black holes, naked singularities could briefly emerge. If such an event were observed, it would challenge the foundations of general relativity and open the door to entirely new physics. The detection of gravitational waves has also led to a startling realization: black holes are not static, isolated objects. Instead, They are active participants in the dynamic, evolving universe. Their mergers, spins, and interactions with other cosmic objects influence the fabric of reality itself. For instance, when black holes form in binary systems, pairs of massive stars orbiting each other, their eventual collapse can lead to fascinating phenomena. If one black hole gains mass from its companion star before collapsing, the system can become a source of ultra-powerful gamma-ray bursts, some of the brightest and most energetic events in the universe. Black holes, as engines of cosmic evolution, is another concept that has emerged from recent research. When matter falls into a black hole, it doesn't simply vanish. It releases tremendous energy as it accelerates toward the event horizon. This energy can drive powerful jets of particles and radiation, which stream out into space at nearly the speed of light. These jets can influence the formation of galaxies, regulate star formation, and even shape the large-scale structure of the universe. In this sense, black holes are not just destructive entities, they are also creators, playing a vital role in the cosmic ecosystem. But what about the possibility that black holes are more than just cosmic engines? Could they hold the key to understanding the deepest mysteries of reality itself? One tantalizing idea is that black holes might be linked to the fundamental nature of time. Time, as we experience it, flows in one direction, from past to future. But inside a black hole, time and space are so warped that this distinction begins to break down. The singularity at the center of a black hole is often described as a point where time ceases to exist or where all possible timelines converge. This leads us to the mind-bending concept of time travel through black holes. While popular science fiction often portrays black holes as portals to the past or future, the reality is far more complex. The intense gravitational forces near a black hole could, in theory, create closed time-like curves, paths through spacetime that loop back on themselves. However, such curves would be incredibly unstable, requiring exotic matter to prevent them from collapsing. Even if they could exist, traveling through them might create paradoxes, such as the infamous grandfather paradox.